All right, so very good evening, guys. The topic that we talk about today is basics of structure of atom. Typically, class 11th, chapter 2, structure of atom or atomic structure, and the topic here, which is called as the basics of structure of atom. Quickly, we'll check the audio and then we start with typically class 11th chapter 2. Absolutely fine. So the audio is all okay. Yes. And here we start the basics of structure of atom, right? So how we start this chapter in class 11th? What all are the basics we should be knowing about it? Because in our childhood days we used to learn it was Dalton's atomic model, wherein it was atom was indivisible, atom is the smallest particle. But then we moving forward we realize no, it is not the smallest particle, it has subatomic particles also. Then same atoms we'll discuss one on one. It was Dalton's theory to be very precise. So when we talk about structure of atom, we need to think about that the structure of atom, this atom itself is made up of two words, which is atom, and that atom means uncut. Atom itself is made up of two words, atom, which means uncut, which could not be cut further, which is the smallest particle existing. That is called as the atom. So eventually the first time the term was coined and the first atomic theory that we got was something called as Dalton's atomic theory. Was called as Dalton's atomic theory. When we say Dalton's atomic theory, we always mean to say that atom is the smallest known particle. That is, atom is indivisible. It is the smallest known particle, right? Then Dalton also spoke about same element, same element cannot have different type of atoms, cannot have different type of atoms, right? And similarly, different elements cannot have same type of atoms. So these three typical clauses that we talk about was given by the first theory of atom, which was called as Dalton's theory. Which was called as Dalton's theory. Right? Which is called as Dalton's theory. Now here to note here, what do we take about is that atom is indivisible. It is the smallest known particle. That means it was actually abolished with the fact that the fact now is atom do have subatomic particle. Atom do have subatomic particles. Means this clause is no more valid for now. Atom, yes, it is there. Protons, electrons, neutrons are the bare minimum subatomic particles that we talk about. Right? Same atom cannot have different type of atoms. This is also wrong in present day. wrong in present day. Why? Why it is wrong in present day? Same element cannot have different type of atoms. Why? Because remember isotopes. Example, isotopes. Fact is isotopes. And isotopes are the atoms of same element, but they are different atoms. Remember, isotopes are the atoms of same element. Me pen it down here. Isotopes are the atoms of same element. Isotopes are the atoms of same element having same atomic number but different atomic mass. Means it is an example of same element but different type of atoms. It is an example of same element but different type of atoms. Same element but different type of atoms. Similarly, different elements cannot have same types of atoms. This is also wrong in present day. Wrong in present day, comma. Fact is isobars. Fact is isobar. And what is isobar? Sir, isobars are the atoms of different elements. Isobars are the atoms of different elements. Isobar the atoms of different elements having different atomic number but same atomic mass. Very important. So these three findings actually reduce the value of Dalton's theory year on year as we move forward. And now Dalton's peculiarity is something that yes, he founded the atom, he discovered the atom. Atom in terms of biology was that was cell. Cell was discovered by Robert Hooke. Atom was discovered by Dalton. So here when we talk about isotopes, example can be mentioned as say H11, H12 and H13 are the three isotopes of hydrogen. Three isotopes of hydrogen. Parallelly, isobars are the atoms. Examples for isobars are argon 1840 and calcium 2040 are the examples of. It's a combination which is an example of isobar. Right? Done? Good. So after that, when we actually started with studying the atom, the first model that came about was Thomson's model. Thomson's plum pudding model or the watermelon model. right? Thompson's plum pudding model or watermelon model. It mentioned as if in a watermelon, in a watermelon, the red portion depicts positive charge. The red portion depicts positive charge, and the black seeds show negative charge. Show negative charge. It means that it means that note atom is electrically neutral. Electrically neutral. Atom is electrically neutral means the amount of positive charge means the amount of positive charge and negative charge is equal. Amount of positive charge and negative charge is equal. Just pen this down first very quickly and then we take to the next topic which is called as Rutherford's model. Quickly, you can copy that in a minute and then we can start the next model which is called as Rutherford's model. Quick All right, so this part is copied. After Thomson's model came the one which is called as Rutherford's model, and that talked about certain facts and figures. Rutherford's atomic model, wherein they spoke about something which is called as Rutherford's atomic model, wherein they spoke about Rutherford's gold foil alpha particle scattering experiment. Right? And what did we do there? What we did was there was a gold foil that we took. Right? This is alpha gold foil, and there we start through alpha particle. We are throwing alpha particle through a gold foil. Remember, what is alpha particle? It is He2 plus, popularly known as doubly charged helium atom. Doubly charged helium atom. So when these particles start passing by through the gold foil, you see maximum particles passed straight through. The first observation was that maximum alpha particles passed straight passed straight passed straight through the gold foil without any deflection. Without any deflection. And the conclusion for it was that most of the atom is hollow. That is, most of the atom is hollow. Right? The first observation was that almost all the particles passed straight without any deflection, which tells about that most of the atom is hollow. My second observation was some of the alpha particles got deflected from their path. Some particles got deflected from their path, which actually tells you about the conclusion that you have, and that conclusion is that there's a center of positive charge, that there's a center of positive charge within the There's a center of positive charge within the nucleus. And this was the term he coined. Nucleus was the word given by Rutherford. Nucleus was first coined. Nucleus was first coined by Rutherford. Right? Nucleus was first coined by Rutherford only. So there's the center of positive charge in the nucleus, and that center of positive is called as nucleus. The point number 3, which is the observation, is 1 out of 10,000 particles 1 out of 10,000 particles got deflected in the same path. Got deflected on the same path by which it had come. Same path. Right, by which it had come, and the conclusion is that the center of positive charge is very small and very dense. Right, conclusion is that the center of positive charge is very strong. The center of positive charge is very strong and very dense. Center of positive charge is very small and very dense, which means center of positive charge, now called as nucleus, is very dense. Right, is very dense. Dense नहीं है, dense है. DENSE is very dense. Right, is very dense. That was given by Rutherford. But yes, the problem was Rutherford could not explain. Rutherford Rutherford could not explain the stability, could not explain the stability of the atom. Could not explain the stability of atom. According to him, the atom should have collapsed. As per his theory, comma, as per his theory, comma, electrons should fall into nucleus, should fall inside nucleus, should fall as per his theory, comma, electron should fall electron according to the, okay, first note this down quickly. Quick, you can note it down, very very quick. Quick, you can note it down. Alright. As per his theory, electrons should fall inside the nucleus due to acceleration, which results in the loss of, which results in, which results in, acceleration will result in electromagnetic radiation, and hence should collapse. And hence should collapse, therefore, and hence should collapse, therefore, and hence should collapse, therefore, Rutherford could not explain the stability. Could not explain the stability. Could not explain the stability. Right? So that was the problem of Rutherford, that he could not explain the stability. Now here I talk about two more basics. One is called as atomic number. The other one is called as atomic mass. Quickly, we do this, we end it in next 10 minutes. So atomic number is actually equal to number of protons in an atom. Number of protons in an atom. Remember, no two elements can have same atomic number. That is, atomic number is your main catch-up thing. Your periodic table is on the basis of periodic number, your atomic number. Today, no two elements can have same atomic number. Cannot. No two can have same atomic number. No, 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 no. And that is the basis of periodic classification. Basis of modern physics. Basis of modern periodic table. Right? Basis of modern periodic table is that no two elements can have same atomic number. Similarly, but since atom is electrically neutral, since atom is electrically neutral, comma, Nayan Roy says, I am your old student. Hi Nayan, how are you? I identified you, Baba. A little I get. Oh, some police siren is going on. Okay. Since atom is electrically neutral, comma, that means my negative electronic charge is equal to proton charge, which means number of electrons equals to number of protons. And if that is the case, remember atomic mass is a measure of it is a measure of mass of an atom, which is typically mass of the nucleus, which is typically mass of the nucleus, which is typically mass of the nucleus. Okay. Now, mass of the nucleus will have two components, number of protons plus number of electrons. What? Mass of protons plus number of what? Not electrons, number of neutrons. Very, very important. Very, very important. Atomic number is only proton or electron, whereas atomic mass is for proton plus neutron. And remember, guys, proton and neutron together are called as nucleons. Protons and neutrons together are known as nucleons. Very, very important. Protons and neutrons together are called as nucleons. So now two things to take up with this very small concept. What? That atomic number is equal to number of protons. But since number of protons are number of electrons, but since number of protons are equal to number of electrons, comma, therefore atomic number equals to number of electrons also. Right? Number of protons plus number of is equal to number of electrons also. However, the first definition is always the atomic number is number of protons. This is always the first definition. Always, it is your proton dependent stuff, right? Now, one thing, let me tell you guys here, a question that has been there in NEET PYQs and even JEE PYQs, which is isotope. When I talk about isotope, are the atoms of same element, atoms of same element, atoms of same element, which means, say for example, if I talk about H11 and H12, H11 and H12, comma, same elements means same atomic number. Same atomic number. Same atomic number means same atomic number means same atomic number means. Okay, there's Kashish who says it's very bad teaching and therefore only I am seeing it. Wow. Now, Kashish, I didn't realize this. I'm so sorry. If it is bad, then why even you are staying? And if you want all your competition to go away from this video, then it is okay. All your competition, and I am not wasting your time. Don't worry, yaar. Absolutely don't worry about it. Anything that you learn from this video will always be more helpful. I assure you this. But yes, if it is a little time waste for you, not a problem. You can leave the video. Absolutely fine, Baba. Why do you want to trouble yourself? Right? No need to trouble yourself. No need to trouble yourself, boss. Good one. So, same atomic number means same proton and same electron. However, however, different neutrons. He's back. Okay, Kashish is again back. Not a problem. Hi Kashish, how are you? Whereas when we talk about isobars, whereas when I talk about isobars, When I talk about isobars, I always talk about atoms of different element. Atoms of different element. And when I say different element, I always mean to say, for example, if I talk about argon and calcium together, which is argon 1840 and calcium 2040, you see here different protons, different protons, different electrons, and different neutrons also. Nothing is common when we talk about isobars. Nothing is common when we talk about isobars. Yes, isotopes, you have same proton, same electron, but in isobars, you have absolutely nothing in common. So remember, this is isotope versus isobar, right? This is about your second, and what do I say? Rutherford got it explained that but yes, Rutherford also talked about the circular orbits. Rutherford also talked about the circular orbits. Rutherford also spoke about the electrons revolving around the nuclear charge around the nucleus. Rutherford also spoke about the electron revolving around the nucleus, electrons revolve in circular orbits, which were called as stationary orbits. Stationary orbits, right? Which were called as stationary orbits. Rather, stationary orbits was a term given by Bohr's model. Term given by Bohr's model. So technically the definition should be only till in circular orbits. This is as per Rutherford's model. As per Rutherford's model. Alright, this is as per your Rutherford's model. This is done and this is important as well. Nucleus, Rutherford coined about it. I also spoke to you now that the combination that we have is nucleus inside, and nucleus has all nucleus has all positive and negative charge. Nucleus has all positive and neutrons. And what rotates outside nucleus is the electron. And electrons rotate in certain orbits. Electrons rotate in circular orbits. Right? So that is about your Rutherford model and the basic, because the next theory that was given was called as Bohr's atomic theory. Bohr's atomic model, wherein the concept of stationary orbits was given. The concept of stationary orbits was coined. Stationary orbits was fine. And what are stationary orbits? They actually mean to say that only those atomic orbitals are available, only those atomic orbitals are available, comma, only those atomic orbitals are available, comma, where the angular momentum, where the angular momentum of the moving electron, of the moving electron remains quantized, remains quantized. This is very important. This is called as Bohr's quantization rule. Bohr's quantization rule, right? And the formula for it is mvr mvr is equal to nh upon 2 pi. mvr is nh upon 2 pi. mvr stands for angular momentum in physics. Angular momentum, right? And nh upon 2 pi means it is quantized. So that was given by Bohr. Parallelly, the most important to remember, Bohr's model was applicable. Bohr's model was applicable to single electron model only. Single electron model only. Single electron model only, which means it is applicable to He plus, Li2 plus, and so on. Single electron model only. Bohr's atomic model is applicable. Then even Bohr gave the formula for energy of electron. Bohr also gave two important formulas for us. Two important formulas. First is radius, that is radius of nth shell. Radius of nth shell, which means that it is Rn is equal to A naught n square by Z. Right, which A naught is 52.9 picometers. So ultimately it boils down to my radius of is 52.9 into n square by Z, and that is happening in picometers. That radius is calculated in terms of picometers. And last but not the least, it also talks about the energy of the electron, energy of the electron in nth shell, and that itself is called as A naught equals to, not A naught, it's E minus 2.18 10 की power minus 18 z square by n square. Very important. Minus 2 10 की power minus z square by n square. Two things to take away from here, that my Rn is proportional to n square by z, and here we are proportional to z square by n square. Z square by N square. Now this is very very important, where Z is the atomic number, where Z is the atomic number of the hydrogen like atom. So typically when I say Li2 plus, then I mean to say Z equals to 3, because Z is 3 for your lithium. So this is how the very basic part of the structure of atom has to be read through and has to be taken the reading from NCERT also. It is very basic. Remember, your first 6 pages of this chapter are pure worth reading it. Please do that, because there might be an assertion reason question out of it. Remember, it is really, really important to read the starting pages of the NCERT. But yes, this is how the basics of your structure of atom is in total. After Bohr, we have the Planck's theory, then Heisenberg, then everything starts. But here, I'm so sorry. When we talk about basics of structure of atom, they should be taken before the Bohr's atomic model has been started. Do not waste much time. Just quickly read those 5 pages in the NCRT, so that the next class becomes really magical for you, wherein we talk about spectrum, the Planck's theory, and the photoelectric effect. One by one each class, but yes, first of all, the reading of the 6 pages in the NCRT. Fine? Chali. Take care, guys. Have a very, very nice evening, and God bless you all. Bye bye.